Hey guys, Branko speaking. This episode will be all about improving your embedded application. This is the third migration episode in the from MikroC to NECTO series. Second episode was all about how to migrate a project from MikroC to NECTO. And the first episode was all about why to migrate to NECTO in the first place. So let's go. Here are the 10 steps for improving your embedded application. The first step would be ditch the cables, go wireless. The second step would be embrace cross-platform compatibility. Third step, use open source and modify it as per your needs. Step number 4, learn from pre-made examples. Step number 5, test your app remotely. Sixth step, code once, run on multiple MCUs. Seventh step, pick toolchains as you go. Step number 8 would be build your project with the standard recognized worldwide. Step number 9 would be plot data from sensors in real time. Step number 10 would be get an idea for your next application from over 1 million pre-built projects. These were the steps for improving your embedded application. Now let's argue about each step together. You will be able to program and debug your embedded applications wirelessly with the help of the Code Grip, which is a debugger device that operates over Wi-Fi. And why go wirelessly? I think that you will be able to move around your workspace without being tethered to your hardware. Saying goodbye to messy cables and complex setups is another benefit. With Wi-Fi connectivity, all you need is a stable wireless connection. And benefit number 3, program and debug from anywhere within your Wi-Fi network, giving you the convenience to manage your projects even from a distance. And if you are concerned about security, SSL is here, which is going to encrypt communication, preventing any unauthorized access during the programming or debugging or Wi-Fi. And how it works? Well, step number 1. Acquire Code Grip debugger with both Wi-Fi and SSL license. Number 2. Make sure Code Grip Suite is installed on your machine. Then connect to the Code Grip with USB-C cable in order to configure wireless communication. Then run Code Grip Suite would be the step number 4. Okay, now connect to the Code Grip debugger by selecting Code Grip, then scanning, then scan devices. Now connect to the Code Grip debugger device. Okay. Set up wireless communication by selecting Configuration, then Wi-Fi General, then Enable Wi-Fi Interface. Then place Wi-Fi into station mode in order to connect the Code Grip debugger to your home or office network. SSID and password must be as same as your home or office network SSID. Now store this configuration and detach USB cable. Just leave the power cable on. The final step would be to start programming and debugging wirelessly, enjoying the freedom to move and work as you please. Once again, ditch the cables, go wireless with NECTO and Code Grip, and transform the way you develop. Work on your projects from any operating system, whether it's a Windows, macOS or Linux. It doesn't matter because NECTO Studio adapts to your preferred environment. What would be the benefits of cross-platform compatibility? Benefit number 1. Ensure that your code behaves the same way regardless of the operating system. Benefit number 2. Save time by using a single dev environment for all your development needs, which eliminates the hassle of switching between different environments. Benefit number 3. Easily collaborate with team members who might be using different operating systems. What you will get is streamlining your workflow and enhanced productivity. Embrace open source. And why would you do that? Well, with over 1500 Atom boards we produced so far, all of them are using open source software in order to be developed, tested and finally deployed into embedded applications. Often when you want to use open source, you want it to be standardized. Well, we standardized our code which runs those Atom boards into SDK framework. This SDK framework is called MikroSDK. But why would you use MikroSDK or any open source software in the first place? Well, because of two things. its transparency, and its cost effectiveness. Let's explain transparency. You will be able to access the complete source code, allowing you to understand, modify, and improve this open source code to fit your specific needs. Now let's explain cost effectiveness. Save on licensing fees and enjoy high quality development without the associated costs. Now let's understand open source a little bit better. How to learn to write embedded applications with MikroSDK? My response would be, learn from 1500 examples we already made. Once again, 1500 of the add-on boards, we call them clickboards, and 1500 of code examples to choose from. And how would you start? Just download a clickboard package, and what you will get is a simple working example of the clickboard you selected. This example is written in C programming language. It uses MikroSDK in the background and CMake as a build option. Then you can combine multiple clickboard packages to create powerful embedded application based on MikroSDK open source project. And this is how you learn to design prototypes, fast and smooth. Planet Debug, possibly the real game changer. This remote hardware access feature lets you test your applications in real time from anywhere in the world. Planet Debug allows you to connect to actual hardware setups remotely. This means you can test your applications on real devices without needing physical access to them. You are free to monitor, modify, and debug your applications in real time as they run on remote hardware. This feature not only saves time but also accelerates the development cycle by enabling immediate feedback and troubleshooting. And by the way, no matter where you are, as long as you have an internet connection, you can access Planet Debug. This ensures that geographic location is no longer a barrier to efficient and effective hardware testing. And how to start using remote hardware access? Choose the appropriate hardware setup from the Planet Debug options available. Choose already made clickboard application. Finally, upload your application to the remote hardware and start testing. Monitor the behavior, debug issues, and refine your code, all in real time. Why would you choose Planet Debug and NECTO Studio? This combination is suitable for a wide range of applications and industries, from automotive to consumer electronics, and you will accelerate development cycles and reduce time to market. With the support for over 2000 microcontrollers, NECTO Studio allows developers to truly code once, run on multiple MCUs. You write your code a single time and gain the flexibility to deploy it across a wide range of microcontrollers. This means that you can switch between different microcontrollers without rewriting your code. How to start using this benefit? Well, let's open some predefined Planet Debug application. This setup has some clickboard and a microcontroller on it, which is typical for embedded applications. I will disconnect from this setup and I will connect to some other setup which has the exact clickboard but with different microcontroller on it. See, the whole application is building, which is code once run on multiple MCUs at its finest. What would be the key benefits? You will eventually develop applications faster by reusing code across different projects and MCUs. You will easily adapt your projects to new microcontrollers as your requirements evolve. You will maintain uniform codebase that is simple to manage and update. I think that's a fair assessment. Wouldn't you agree? If you remember the previous example I exhibited, you could have witnessed the fact I swapped the toolchains as well. One of the standout features of NECTO Studio IDE is its support for multiple toolchains. With 12 different toolchains available, developers can switch between them based on their project requirements. This flexibility ensures that you can always choose the most suitable toolchain for your specific needs, without being locked into a single option. With the integration of CMake as a build option, you can now build your project with the build standard, recognized worldwide. This ensures that your projects adhere to industry standard practices. With NECTO Studio's plot feature, you can visualize sensor data dynamically as your application runs. This capability is invaluable for debugging, testing, and refining your application. By seeing real-time data, you can immediately understand how your sensors are interacting with the environment and how your application responds to these inputs. Combined with the intuitive interface of NECTO Studio, you can quickly set up your project, configure sensor inputs, and start plotting data without needing extensive setup or complex coding. Need inspiration or a solid starting point? We developed Embedded Wiki specifically for this purpose. With over 1 million pre-built embedded projects, you are sure to find ideas and solutions that fit your needs. Embedded Wiki offers detailed documentation, code examples, and step-by-step guides, making it easier than ever to bring your concepts to life. Okay, that's it. This was a guide to unlocking maximum potential of your embedded application. In the episode number 1, we talked about migration from MikroC to NECTO Studio, which is telling us migration opens up a world of possibilities. In the episode number 2, we actually migrated an application from MikroC to NECTO Studio, and it was refreshing. This episode, the third installment, was all about upgrading your project to get the most out of it. 3 episodes, 3 steps to take your prototyping to new heights. So, explore NECTO Studio. And now, until the next one, I will say goodbye.